Now, if we take the possibility of crossing over out of the equation, we still get genetic variability just through the process of meiosis 1 and meiosis 2. And that's through a situation called independent assortment. So when the genetic material aligns on the metaphase plate, it doesn't all have to align like all the paternal on one side, which we see in this example, and all the maternal on the other. It can align in various patterns, which we can see represented here. And just from the way it aligns, look at all the different possible haploid combinations that we end up with. So genetic variability results in gametes from crossing over and from independent assortment. Here's a summary of the process in a male. So here's our male germ cell, which is found in the male gonad or the testy. And this is the diploid cell before synthesis. Here, synthesis of the genetic material has occurred, and we are in the process of starting our meiotic divisions. As we progress from left to right, we can see our meiotic process is occurring. Here is the end of meiosis 2, where we have a cell that now has 2 chromosomes, which is half of what we started with. We started with 1, 2, 3, 4. So our cells are haploid. And if a crossing over event had occurred, which is not represented here, we would have even greater genetic variability than what we're seeing. At step 4, we have differentiation, where these cells become specialized to be motile by the formation of a flagellum. Here's basically the same process. We're undergoing meiosis 1 and meiosis 2. Here's our female germline cell, which would be located in the ovary of the female. It has 4 chromosomes, that's diploid. Here we see we formed an egg that only has 2 chromosomes, that's haploid. You might kind of at first glance say, well, this doesn't make any sense because we only have 2 cells formed here and one cell's huge compared to the other. Whereas with the male, we formed 4 cells, each cell equal in size. Well, what happens is with meiosis 1 and 2 and germ cell formation in females, because the female is providing all of the cytoplasm and organelles, the egg cell is much larger, and it needs to be much larger, I should say. So as we go from our divisions of meiosis 1 and meiosis 2, our cytoplasm does not equally divide, it unequally divides. But we still need all the divisions to occur so that we end up going to a haploid state. So yes, you still have meiosis 1 and 2 in a female, but you don't have equal cytoplasmic division. The egg, in essence, needs to have more genetic material than, the egg needs to have more cytoplasmic material than it would have if the cytoplasm equally divided. And here's an actual photograph of an egg. This is the large structure with multiple sperm trying to fertilize the egg. So in summary, there's 2 forms of cell division, mitosis and meiosis. Mitosis has prophase, metaphase, anaphase, and telophase. It has 1 nuclear division, and in that nuclear division, we end up with daughter cells that are identical to each other and to the parent cell. Meiosis is forming for the purpose of gamete formation, so we're going to end up with haploid cells instead of diploid cells. So from our diploid cells, we want to go to haploid because we're going to join through fertilization the genetic material to make a whole individual. Because we're going to do that, we need to go through the phases twice. So meiosis is divided into a meiosis 1 and a meiosis 2. The end result of meiosis II is half the genetic material from the parent cell that we started with genetic variability. So in comparison, these are side-by-side comparisons of an overview. In mitosis, you start with a diploid cell and you get diploid cells. So from one parent cell, you get two daughter cells. Whereas in meiosis, you start with a parent cell that's diploid and you end up with 4 haploid cells. That concludes the presentation for week 5, chapter 12. I hope that this has been helpful, and I wish you all the best in your studies, and I hope that you've learned a lot about life and how amazing life is. We've just barely scratched the surface of the study of life through biology, but this course should have given you a very good foundation on life's structures and then how those structures function.